Hi everybody. So in this session I thought we'd have a little bit of a look at the TinyPico board that I've mentioned to you before, and I thought we'd try and do something fun. We'd have a little look at running Cheerlights on it, which I'll explain to you. So in the previous sessions we had a look at this little fellow. If you can sort of see him there, that's a TinyPico board. Pretty tiny, isn't it? And that's an ESP32 based board, which is really pretty fully functional actually. If we have a look at the web page for the TinyPico, here we are, tinypico.com. ESP32 board, 240 megahertz, all sorts of bits and bobs on there. So as you might expect, that's got the 2.4 gig Wi-Fi, it's got Bluetooth BLE, it's got flash, it's got RAM, it's got a nice little RGB LED that we're going to play with, and various other bits and pieces. You can go and have a look at that. Really nice little board to play with. Then what we're going to do is to use the Arduino Ide that we set up in one of the previous sessions, and we're going to program with that integrated development environment, the IDE, and we're going to put some code onto this little board, make it do things, connect it up to the internet. This is all about the Internet of Things, isn't it? So let's do that. You don't need to run in a virtual machine. I do tend to do that. I've mentioned before that I use that because it keeps what I'm doing nice and isolated from the host system I'm running on. And if you want to do that, you can go back at one of the older sessions, which I take you through how to set that up. You don't have to. You can install everything on your host system if you prefer. What you will need to do is to have set up the Arduino IDE, which you can see here. And again, I've taken you through all of that in one of the previous sessions. So if you're unsure about that, go back to the YouTube channel and you'll be able to see where we go through that. In fact, if you look at the Dynamic Devices IoT training on the YouTube channel, you'll see that the last session, number 3, was installing the Arduino IDE. There's a couple of specific things that you needed to do with Arduino, so if you already know all about that, I'll just remind you that you needed to go to the preferences and add in a specific link to get ESP32 board support, and then that gives you a whole host of ESP32 boards. One of those is the TinyPico that we're going to use. So again, any confusion, go back, have a look at that previous session. That will help. Next, let's have a look at how to use the TinyPico. Again, we can use different kinds of programming environment to write code for it. If we go to tinypico.com code examples, you can see there up at the top, then they talk about MicroPython. It's a great way of doing things. We'll talk about that in another session. That's a sort of an embedded subset of the Python programming language, which you might be familiar with. Or alternatively, you can use Espressif's framework, the IDF. You can use that with Platform IO, which I tend to use, which is pretty good. We'll talk about that another time. But for the here and now, we'll talk about the Arduino IDE, because a lot of people use that. A lot of people like it. It's a good way of getting started. And that's documented somewhere around here. Okay, there's a helper library for the Arduino IDE, and that's really useful to us. What that kind of means is that the people who created the hardware, created the board, they put various features on that board, like the RGB LED that we care about, and to make life easier for us, they've written some code to get us up and running so that it's easier for us to talk to that RGB LED and other components on the board, because otherwise we'd have to write the code or find the code and do all sorts of messing about. And particularly when you're trying to do engineering, you have lots of different things that you have to think about, worry about. So it's quite nice if you can treat things as a black box. I don't want to have to worry about how that RGB LED works right at the minute. I just want to tell it to be a color, and that's what this library is going to help me to do. So let's have a look at how we can find that library and add that library into our code. So if I look for TinyPico Arduino, I've run up my Arduino Ide as you saw, and if I go to Tools, or rather Sketch, Include Library, Manage Libraries, that pops up, and there's all sorts of stuff in here. So I'm just going to do a search for TinyPico, and there you go, there's the TinyPico helper library, and I can install the latest version, which is 1.4.0. that downloads and plugs into the Arduino Ide. So I've now got support for the functionality, the hardware on the TinyPico board, so that's great. One thing that I do need to remind you to do, we went through this in the setup guide, but if you go to Tools, you need to choose the board that we're going to build for. And here you can see that I've chosen the ESP32 Arduino TinyPico board, and we've got that available to us because of that ESP32 link that we added earlier on in the preferences. So you'll need to have that set up so that you can compile for this particular target board, so don't forget to do that. You can also choose the port when you have your device connected, which will probably be something like dev tty USB 0. So there you go with that. Here I've got the standard basic getting you started sketch, which we talked about in the previous session. Again, this is wrapping the C++ programming language to try to make it a little bit more straightforward to get going with it. We have two starter functions, setup and loop. Does what it says on the tin really. Setup is run once when your application starts up, and that's for setting things up. And loop is running over and over again as long as your application is running, and that will just keep doing the same thing over and over. And of course you can add your own functions in here. Now, I have already been through and put together some code to do the things that I want to show to you, and you can, if you want to, leap ahead and go and have a look at the GitHub website. So if I take you to Dynamic Devices on github.com. In there you will see IoT course, and this is where I'm building up a resource for you of links to these getting started videos and some source code that might be of use to you. And here we've got the Cheerlights source code which I've been testing out and working on. So you can, if you want, clone that from the Git repo, and the way that we do that is we go to, again, github.com dynamic devices IoT _ course, and there's a code button here where we can click to copy the link to clone this source code. There's a couple of different ways you can do that, HTTPS and SSH. HTTPS, you don't need any passwords or login or anything like this because this is all public and open source. So use that. As I say, you copy that. Then let's go to open up a terminal shell on our virtual machine. So I'm inside the virtual machine here now. And I'm going to git clone the link that I copied from the GitHub site. And that pulls down the files. There's only a couple of files in there now, so it's very quick, into an IoT course directory that it creates. And if you see in there, there's a Cheerlights folder, 04 TinyPico Arduino Cheerlights, and in there we've got a cheerlights.ino file, which is the source code for the Arduino sketch. And we could just open that up and run it, and that would be fine. But I want to take you through what we're trying to do with this here, so we're going to go step by step. Now, also what I want to do here is to plug our RGB LED on this TinyPico board into something called MQTT and into something called Cheerlights. So it's worth having a little chat about what that's all about. MQTT is a protocol, a software protocol for moving internet information around. It's a protocol for IoT devices to communicate. There are different protocols. I happen to like MQTT because I know the people who invented it, Al and Nipper, my old boss, and Andy Stanford Clark. And for a number of reasons, MQTT is a great protocol to look at. It's designed to be very lightweight for embedded devices, and it's designed to get your information that you care about from one place to another place in an assured way. So you know it's going to get there to the best effort that it's possible to get it there. We could talk all about that at great length, but essentially think of a message that you have on your device. And that might be a sensor reading, or it might be some information that you need to send. And we want that to go from your device into the internet to some kind of computer somewhere. Maybe you want to analyze or display or do things. And MQTT can help you get that message there. It can also transfer messages the other way. So if you have some information on your computer on the internet or somewhere else on the internet, you can send that information through what's called a broker, and it will then magically arrive at your device. So let's see if we can make that happen. To make this a little bit more fun and interesting, we're going to use the MQTT protocol to do some flashy lights, because flashy lights are great. And in this particular example, we're going to use something called Cheerlights. So Cheerlights was invented by a guy called Hans Schaller. Brilliant idea. This is the chap here. You can see a little picture of him. And he just had this really simple and yet beautiful idea that perhaps people could tweet a color at a particular Twitter handle, or with a particular Twitter hashtag tag Cheerlights, and there could be lots of devices all over the world all listening for you to do that. And so when you tweet, say, red to hashtag Cheerlights, all the devices around the world that are listening to hashtag Cheerlights, they will go red, which is kind of wonderful, isn't it? It's simple, and one of the great ideas, simple ideas, great ideas. And what they've added to the support for Cheerlights is that Cheerlights now supports MQTT. So what I can do is I can tweet at Cheerlights, and if I have an embedded device like my trusty TinyPico here, and that's connected to the internet, this is going to be connected over Wi-Fi, and it is listening on what we call a topic in MQTT, the Cheerlights topic, then it will receive the message that somebody's tweeted that color, and I can choose then to set that color. And that is exactly what we're going to try to do today. So, first thing that we can do is to pull in the TinyPico library. Now that's what we've just installed. That's the helper library, and that's going to enable us to control that RGB LED without having to go to the ins and outs of the bits and bytes and the zeros and ones that we have to actually send to it to make it do what we want. Because it's a black box. We're engineering here. Then there's a bunch of slightly more complicated stuff which we're going to get into shortly. But before we do that, let's just try to do a very, very simple test. Simple tests are always good to show that we know what we're doing, that things are set up the way we want them to be set up. So let's try to set a value into our dot star. A dot star is the RGB LED that we have on this TinyPico board. What I should probably say is that you know what an LED is. We have red LEDs, blue LEDs, different colors of LEDs. And an RGB LED has red, green and blue colors inside it, and you can turn those on in different combinations, And depending on what you turn on and how brightly you turn it on, you can make different colors. So you can make a spectrum of colors with your RGB LED, depending on what you tell it to do. And that's quite a nice thing. So we will create our TinyPico object here, and then we're going to set it to be a color, and I'm going to choose a color, and I'm going to magically make it be that color, which I'll explain to you. So this bit of magic here is just saying we've included a file called tinypico.h, which is the sort of definitions of what is in the helper library. You can go and look those up if you want. I happen to know, because I looked at the example code before, that we create a class which we're calling TP of the TinyPico type, and we then call a function on that TP object to set the pixel color, and we give it a value, and that value is the color that we want to set. And that may look a little bit strange. That's a value in hexadecimal, or base 16. And we use base 16 quite a lot in computing because it makes it easier to see what the numbers mean for various reasons. If we split this up into 3 sections, there's an FF and a 00 and another 00. I've got one too many there. And the way we define this for our RGB LED is that the FF is the red color, and then the 00 is a green color, and the other 00 is a blue color. So we put these together in an RGB format. And in base 16, you can have numbers from 0 to F. So 0 to 9 are what you'd expect, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, an A is a 10, a B is an 11, up to an F, which is a 15. And so if you worked out what FF means in base 16, that's 255 in decimal. And that's the maximum value you can have with 2 digits or a byte of base 16. Don't need to worry too much about that. All you do need to think is that that FF is the maximum redness that we can have, 255 full on red. And this is the minimum blueness, greenness, excuse me. So there's no green and also there's no blue. So this number should give us full on red if we program this into our TinyPico. So what I'm going to do is to try to compile that sketch. I'm just going to save that. That's compiling up. Fingers crossed. It's getting there. And it's done. And it told us that it's taken 17% of the storage space and so much RAM and so on and so forth. That's not entirely accurate for a couple of reasons, but we don't need to worry about that. So we've built it up. Now I have my trusty TinyPico on a USB-C cable connected to my physical computer. And as we talked about in one of the older sessions, you need to route this through to the virtual machine if you're using the virtual machine. I have this set up to do that automatically, and what you can see is that we've got a Silicon Labs USB to Uart connector. And all that is that the ESP32 chip on here has a serial connection, and that needs to be converted to be able to connect it up to the USB that most of us have on our laptops and our computers. So it has a chip on there to do that, which is the CP2104 chip. There are different ones. That's what these people have chosen to use. And that really just sort of sits there and it moves things from USB into the chip over the serial backwards and forwards. And that just makes everything a lot easier than having to deal with serial connections, which are old school and can be a bit of a pain nowadays. So if you needed to, you would check that box to connect your device up to the virtual machine. and I go through all of this in the previous one of the previous talks, so again, any confusion, just go and have a look at that. And we're now connected up, and what we should be able to do is to upload that sketch into our TinyPico over the USB connection. And it's trying to connect to the device now. Doesn't seem to be very happy. Oh, there it is, it's figured it out. So it's writing 25%, off it goes. That's writing the information into the flash on the ESP32 chip. And it's reset it, and oh my word, if I turn that the right way around, I've got a red LED. How easy is that? We're IoT programmers. It's brilliant. Now, you may not believe that we really did that. You know, maybe there's just a red LED on there, and I'm just fooling with you. So let's prove to ourselves that this is really doing what we want it to do. I'm going to change my number. We talked about RGB, didn't we? So I'm going to change this down to no red and full-on green, 255 or FFX green. And then what we'll do is we will upload it as well. It knows it needs to recompile it. It's clever enough to know that. So it's now recompiling and re-uploading to the TinyPico board. You can see it's trying to connect. Have a slug of my tea while it's doing that. Yeah, it's not entirely happy. So sometimes what you need to do with these things is you just need to give them a prod and reset them. There's a reset button on this, which I can't see because the LED is on so brightly. But if I find that and I push the reset link there, reset button rather, let's try uploading again. See if that does what we need it to do. Yeah, it really is having some problems. Let's try reset as we go. There we go. So I reset it, it's sorted itself out. What's happening is that when it tries to send data through to the device, they have a little sort of communication protocol that they talk backwards and forwards. So the program on my machine is saying, are you there? Are you listening to me? Are you ready for me to send you some information? And it needs to get that back. And if this is busy running a program and doing other things, then it's not responding. And so it's saying, well, where are you? What's going on? And as if by magic, we've gone from our red color of our RGB LED through to a green color. So you can see I wasn't fooling with you, and we can set this into all sorts of different colors. Isn't that amazing? Great. So that's pretty cool. But again, we're doing IoT. So let's do something even better. And let's try to connect this little board up to the Wi-Fi here and out onto the interwebs. And then let's see if we can try to control it from the internet, because that's kind of what all this Internet of Things stuff is about, isn't it? So I'm going to just take out that test line that we put into the setup function, and I'm going to start doing some other things to get us onto the internet. One of the difficulties nowadays with engineering is you know, we shouldn't complain, but there's so much open source software out there, freely available software. It's wonderful. You know, when I started out, none of this stuff existed. Everything, more or less everything, was proprietary. It's quite hard to get bits of code. It was a very slow process. You certainly couldn't just Google and download something and use it. So that's brilliant. Life has changed, the world has moved on. But the problem that we have now is that there's so much stuff out there. It's not about how do I do this so much as about which of these 5 bits of software should I try and use, which is the best thing for me to work with. And so the experience, if you like, is all about having an understanding of what you should choose, because some things are a lot easier to work with than others. So for this example, I found the Espmqtt client, which I think is going to be good for what we need, because it's a pretty straightforward MQTT protocol client, with a bit of software to run on this TinyPico device, which is designed for ESP32s, so it's right up our street. We need to pull in that library too, so I'm going to try and do a search for that now. So ESPMQTT client, and that's been found. That's a library that provides a Wi-Fi and MQTT connection for either an ESP8266, which is kind of the older chip. It's really cool, do a lot of stuff with those, and the newer ESP32. Brilliant, just what we need. So let's install the current version of that. And it says, oh, we need some other stuff. It relies on some other libraries. It relies on a PubSub client library. So we're going to need that too. So let's install all of the things that we need to install. And then even have time to have a slug of my tea. That was so quick, my word. Okay, so that's installed now. And what we can do to start to use that ESPMQTT library is to include the ESPMQTT client.h include file. .h files it's the extension that you normally use in the C language for include files, which are generally full of definitions of functions and things that you might need to use. So we're adding in support for that into our code, and you can go and look at the documentation for that. In fact, let's have a quick look at the ESPMQTT client for the Arduino. And as if by magic, this page pops up with the information that you might need. Let's read the documentation, because that always helps. And in here, it gives us an example of how to use this code to do the things that we want to do. And that's exactly what we're going to do. I took this originally and reworked it to create this demonstration for you. So that's fine. Let's move that out of the way. And the first thing that we need to do is to set up a structure which is going to have all the information that we need to connect to a local Wi-Fi access point. So when your phone is connecting to the Wi-Fi or your computer is connecting to the Wi-Fi, that's exactly what we're doing here. And the first two lines here, I should say, we're going to call this a client. So this object we're creating is client, and it's of a type ESPMQTT client, more or less. So guest is the name of the Wi-Fi access point I have here. So that's the SSID. And I have a guest access point set up which doesn't have a password. Otherwise, you would put your own access point and password in there. Those two bits get you connected up to your Wi-Fi and thus onto the internet. Then the next bit is the URL, the address if you like, of the Cheerlights broker. So that's the other end that's sitting there waiting for devices to connect in and talk MQTT and say what they're interested in listening for and send messages about things that they're interested in sending messages on what we've talked about in terms of topics. We can go into that a little bit more later. And lastly, I've got a name for my client, which I've called test client, which should really be unique. So you probably want to change that to something else. If anybody else is using the same name as you, when they connect up to the broker on the internet, it's entirely possible you get knocked off. So put your own random name in there. There's a couple of other settings that you can add into this if you're doing more complicated things, but that's good enough for what we need to do. Next, we want to set ourselves up. So we're going to add in a line to the setup function that we said runs when everything starts up. Serial begin 115200. Now, as I said just before, the TinyPico device, it's got a serial port on it, and that goes through this USB chip we talked about, and that's then connected up to my virtual machine here. So I can use that to send information on what's going on, the debugging output, which is kind of useful. It's nice to see what's going on. It's pretty hard to fix problems if you can't see what the problem is. So we set up the serial port on the ESP32 chip to be ready to go, and serial ports can run at different speeds. Now, this is a historical thing, but what most people would tend to use nowadays is a speed 115200 board. You don't really need to worry about it, and over USB it often doesn't really matter anyway. But if you get odd things happening, you might want to check your serial port speed, and again it's usually 115200. So that gets that set up for us. Then what we're going to do is to add in another line, which I used when I was getting all of these things going, to call the Espmqtt client and call a function on that to enable debugging messages. And I'm passing a parameter to that of true to turn on debugging messages. We don't need to do that, but it shows us more stuff about what's going on inside the library code, which is quite nice when we're trying to get going. The more you know about what's happening, easier it is to get things to work. So let's enable that. And then the next thing that we need to do is the library is doing its own management and work inside itself, and we don't need to worry about exactly what it's doing, but we do need to enable it to do its job. This loop function we said is being called over and over and over and over again. So inside the loop function, we call a loop function of that client that we created, and that just lets it get on with any handling of things that it needs to do internally, like checking for new messages or sending messages or whatever it might be. So if we didn't have that in there, then the library wouldn't be able to do its thing and things wouldn't work. What's really nice about this Espmqtt client is it's that simple. All we needed to do was to tell it the access point we want it to connect to, and where the broker is that it needs to talk to, and what we're going to call ourselves when we say hello to that broker, and all the other stuff is magically happening inside that client loop function, which is a really nice encapsulation of software. It's one of the reasons I'm using this. It's quite neat. Then the next thing we're going to do is to add in what's called a callback function, and that callback function, called onConnectionEstablished, I'm going to put up here above the setup function, and in there I'm going to put a line which is going to output some information over the serial port, and there we go. Now the Espmqtt client code calls a function called onConnectionEstablished when a connection is established. Does what it says on the tin. So what it will do is it will connect up to the Wi-Fi access point, then it will try to connect to the broker at the location that we gave it, and when it's connected okay to the broker, this function will get called, and the code that we've put in this function, serial.println, will print connected to broker over our serial connection. Fingers crossed. There's more that we have to do yet, but we'll leave that for the time being because we just want to take things step by step and prove out what we're doing and make sure that we understand everything and that it's all working okay. So let's verify and compile that. Slug of my tea while we're doing it. And then when that's compiled, what we're going to do is flash it into the TinyPico board using the upload function. There we go, that's compiled. So we'll upload it. Might need to reset this board again, we'll see. That's now programming. So again, that's writing what we've just compiled down to the flash in the chip. It's going to reset the chip, that's going to run. And because of what we've written here, what's going to happen is that the chip is then going to try to connect up to the local Wi-Fi access point called guest, and it's going to try to connect to the Cheerlights broker running on mqtt.cheerlights.com. Now once that's finished, what I'm going to do is to run up one of the tools that are built into the Arduino IDE, which is the serial monitor tool. And that allows us to see information that's being sent out of the serial port on this device and going through that USB bridge chip I mentioned and into the computer. So that's reset now, and what I'm going to do is to run up the tools serial monitor, and then talked about baud rates, didn't we? So this is set to the 9600 baud rate, and I'm going to change that to be 115200 because that's what I've set in the code. And I'm going to reset, and that information is what you get when the chip starts up. So we get a power on reset, some information about what's happening, and then our code starts running. And this is debug output from the Espmqtt client library, because we turned it on, didn't we? And it's saying, I'm now trying to connect to guest, the guest access point, and it connected. How fantastic, it worked. And it's got an IP address assigned by the access point, which is 192.168.1.130. And then with that connection over the Wi-Fi, it's now trying to connect to the MQTT Cheerlights broker with a client name test client, all of the things that we set up. And then, rather wonderfully, we see a message connected to broker, which is what I said we would see when we had a connection established. It's all going well. So we've proven to ourselves that we can connect up the TinyPico board onto the internet and connect to a server running out there on the internet. I don't know where, could be anywhere. And that's brilliant. Now let's see if we can make this into a device that does something. So go back to our example code, and in our onConnectionEstablished function, where we're printing connected to broker, let's grab the remaining bit of this code in here, which is this client subscribe function. And I'm just going to close down that serial, and I'm going to add that in here. And so what will now happen is that when our MQTT client connects up to the broker and the library calls this function, and we print the information about what happened, we then call another function on the client object, if you like, called subscribe. And what this does is this takes a topic, which is Cheerlights RGB, and there's a function which receives a parameter payload, which is a string, and it then prints out what it received, so what is in the payload variable, and then it does a bit of magic, which we'll talk about in a bit, to convert that into a useful RGB color we talked about, and it sends that to the RGB LED. So what we can expect to happen is that if our client receives a message on the Cheerlights RGB topic, that message content is the payload. That's like the letter inside the envelope. The address of the envelope is the topic, and the payload is what's put inside the envelope. And then we take that payload and we use that to set the color of the LED. Now, a little bit about topics. You can choose any topic that you want. You can have strings of topics, and you can have wildcards on topics. So you can, for example, have one device that's publishing on a topic and lots of other devices that are all subscribed to the same topic, and when you publish they all get that information. That's kind of how this Cheerlights stuff is working. So that's really neat. Lots more to talk about there, but we won't deep dive into that too much because we want to do flashy lights today. So we're going to receive something on Cheerlights RGB. We're going to use that to change the color of the LED. Boom, off we go. Let's just double check if there's anything else we need to do. No, that should be okay. Let's try to verify compile that. Another slug of tea. Done. Let's try to upload that to our TinyPico board. And there we go. That's writing the current latest code, if you like, into the chip. Taking a little while. And then again, when this has written and reset, let's run up our serial monitor and what I'll do is just push the reset button to restart it. And you can see again, we connected up to the broker, and this time we subscribed to Cheerlights RGB, and we received a message on that Cheerlights RGB topic with an FDFFE6 code. Now, I don't know my RGB colors off the top of my head, but that's quite a lot of red, quite a lot of green, and quite a lot of blue. So what it's done is to set the RGB to be a kind of a white color. Brilliant. Now, just to prove to you that this is in fact all connected up as an Internet of Things device, we can bring up our Twitter. And we can go to Cheerlights. That's Cheerlights on Twitter, at Cheerlights. And we can tweet. And we can tweet at Cheerlights, or we can just use the hashtag. What color would you like? I'd like pink. So let's tweet Cheerlights pink. And there you go, it's still white at the moment. If I tweet that, that's gone. And then what will be happening is that that tweet goes through the broker, and we're subscribed to the Cheerlights RGB topic on the broker, so we get the pink color. Can you see? Is that pink? It's not particularly pink, is it? I think what we'll do is we'll try blue. Let's go for blue. So if we tweet at Cheerlights, typing one-handed, blue, that's gone. Through the magic of the interwebs, it passes through the Twitter feed, through the broker, and we've just received blue. Amazing. And you can see that from the number again. There's R and G and B. So there's no red, there's no green, and it's full on blue. And just in case you don't believe what I'm saying to you, although I can't imagine that you wouldn't believe me, let's try something else. Let's try for green. Cheerlights green. And if we go back to the serial output from our device, the green command has now been received, and we go green. Isn't that lovely? Cheerlights over MQTT on a TinyPico. Easy to do. If you install your Arduino IDE, grab the code, put it together, and off you go. And you can leave this running, and if anybody anywhere in the world tweets at Cheerlights, a color, your new IoT device will turn that color. So, I hope you have fun with that. Thank you very much for listening, and enjoy your IoT engineering. Bye.